In this lesson, we'll be combining a lot of the techniques that we've already seen to simplify the last bit of functionality in the customer class, generating a statement. We'll be picking up the pace a little bit too, as hopefully you're now familiar with the refactoring so far. Let's go to the customer class. We need to decide how the pricing is going to work. Does each customer have different tariffs and loyalty plans? We don't really know, and we don't have any known upcoming new functionality, so we're going to have to guess. Refactoring can mean that you need to decide what type of features you'll allow, and making the wrong choice can either make things too complicated for possible features that are never required, or make features that are required harder than needs be to implement. So it's best to understand about features on the horizon if possible. Anyhow, we'll take a guess and assume that different customers will have different tariffs. If we take a look at the generate statement method, we can see that the tariff and loyalty plan classes are only used at statement generation time for the purpose of creating the statement. The customer class doesn't use them otherwise. The statement generation then uses only this derived information to create the statement. Let's introduce an intermediate result, the priced rental. Use the Streams API to map over the rentals to convert the rentals to priced rentals. Then use IDEA to create the priced rentals class. Use Alt-Enter to create it, and then Alt-Enter again and bind the parameters to fields to create all the fields and constructor code. Use Alt-R-T to make static, and then make the class and all the fields public. We've made a design decision that immutable objects with no behavior can have public fields. Creating so-called getter methods doesn't actually add any encapsulation, despite what some programming styles may state. Go back and collect the map stream to a list. Use Ctrl-Shift-Space twice to show a valid collector to list. Then Ctrl-Alt-V to assign the whole thing to a variable. iter-tab to create a for each loop. Delete the top of the existing for each loop. Now fix up the calls to the tariff and loyalty plans, making them use the priced rental instead. Move the cursor over the R in Lambda. Alt-Enter and choose Replace Lambda with Anonymous Class. Move over the class declaration and name the class as Price Plan. Now, go back to Generate Statement, select the whole method, extract a new method, Generate, and extract parameters for Name, Rentals, and Plan. Now, move back and follow the same steps as before to introduce a new class, Statement Generator. New Statement Generator, create a variable, create the inner class, add to the call, add to the method, then F6 to move the method onto the new class. Then make the method public and the class public, then static. Check the tests with Shift F10. Now let's require that the statement generator is passed into the generateStatement method. This does make sense, as it would enable the caller to pick a different implementation of a statement generator, say one for a text statement and one for a PDF. Show callers to the generateStatement method with Ctrl B. There are a few, all in the test class. If we did the introduce parameter refactoring here, it would introduce the new statement generator in all the callers, creating lots of duplicate code. So, navigate to one of the callers with Enter, then Ctrl-Alt-M to introduce a method, generate, and use Alt-Y, Alt-A to replace all the usages. Ctrl-Alt-Left, Ctrl-B. Now there's only one usage. Ctrl-B again to move back. Now Ctrl-Alt-P to introduce a parameter. Alt-Enter to remove the useless variable. We now need to make a quick review of the classes we have created, before we make them top-level classes, in case we have overlooked anything. Firstly, the priced rental. This is public and static, and all the fields are final. Good. Next, the price plan. This can't be made a top-level class, as it's not static, and it refers to tariff and loyalty plan from the enclosing customer class. However, we could simply move these fields into the new price plan class and make it static. Let's do that by simply cutting the fields from where they are and pasting them into the new class. Now we can make the price plan class static with Alt-RT and public with Alt-Enter. Finally then, the statement generator. Again, this looks okay. The class is public, as is the method, and there is no state to worry about. We can now use F6 on each of priced rental, price plan, and statement generator to make them all top-level classes. Now our customer class is much simpler. Check the tests again. Good. Still passing. Still, each customer does have exactly the same price plan, as it's initialized in the customer class in the generateStatement method. It would be better if that were passed into the customer constructor. Move the cursor near the price plan and Ctrl-Alt-F to extract a field. Choose Initialize in Constructor. Check the usages of the constructor with Ctrl-B. There's only one. Go back and introduce the price plan as a parameter with Ctrl-Alt-P. Now we can see that the price plan itself only really implements a single price plan, as it instantiates the tariff and loyalty plan fields itself. Repeat the process so that both the tariff and loyalty plan are passed into the constructor. Alt-Enter, Initialize in Constructor, and Ctrl-Alt-P to make a parameter. Test still passing? Yep. Looking back at the customer, they now only know about their name, a list of rentals, and a price plan. The pricing, loyalty points, and statement generation are all handled elsewhere in the codebase, and can be independently tested. Next, we'll try to add some new functionality to our video store, and see if the refactoring has helped.